and welcome to another episode of STEM in Seconds. Today I'm going to take you through the top 10 circle theorems you need to know for your GCSE exams. The first theorem is that this angle at the centre is twice the angle at the circumference. So if this is the point O and that's the centre, and I label this A, B and C, then the angle AOC is twice the angle ABC. Graphically, this angle here is x and this angle here is 2x. Theorem 2 is that angles in the same segment are equal. That means this angle here and this angle here. So x and x. Written out, this means that angle ADB is the same as angle ACB. The reason this occurs is because both of these angles are contained within a triangle that shares this bottom line. Theorem 3 is that opposite angles of a cyclic quadrilateral, that means a quadrilateral shape enclosed within a circle, add up to 180. So that's this angle x and this angle y. Less of a theorem and more of a rule is that if you have an angle, this angle here, in a segment, and the base of that segment happens to be the diameter of the circle, so this is the centre, then this angle here is 90 degrees. So ACB will be a right angle, otherwise known as saying the angle in a semicircle is 90 degrees because the diameter will cut the circle in half. Another right angle rule is when you have a radius of a circle here meeting a tangent, so a line that only hits the circle once, the angle between the two is 90 degrees. So OAT is also a right angle. The posh way of saying this is the angle between a tangent and a radius at the point of contact is 90 degrees. The other most common rule involving tangents is that if two tangents to a circle, in this case A and B, originate from the same point x, then the distance AX is the same as BX. The next theorem is called the alternate segment theorem, often shortened to AST, and it states that when you have a triangle and a tangent and a point of contact between the two, then this angle here, A, this angle here, called B, are going to equal each other. You don't need to know any kind of proofs for this, just that it happens. However, in your exams, they might not let you write alternate segment theorem, so you have to write it out the longhand way, which is that the angle between a tangent and a chord at the point of contact is equal to the angle in the alternate segment. Onto a slightly less wordier one now. Here is my radius and here is a chord, AB, cutting across the circle. And if the radius is bisecting the chord, which means that if AX equals BX, then the angle OXB is 90 degrees. When a radius bisects a chord, they will do so at right angles. On this one I have two chords and I've labelled their point of intersection X. Now this is a little complicated, but bear with me. If I take the distance DX and multiply it by the distance BX, it will give me the same result as if I'd done AX times CX. So I'll just write that out. DX multiplied by BX is the same as AX multiplied by CX. The products of the distances between the edge of the circle and the point of intersection are the same for both chords. Similarly to the last one, when you have lines intersecting the circle in two places, the result of the long distance multiplied by the short distance is the same for both of these. Written out, that means that AX times BX equals CX times DX. Thank you all for watching my whistle-stop tour of the 10 circle theorems for GCSE. Please comment down below if you have any ideas and don't forget to subscribe.